Good day, learners. Today we are doing work, energy, and power. So let's start with work. Work can be calculated by using this formula. W is equal to F times delta X cos theta, where W is the work that is done by a force. It's a work, work. It is measured in joules. So the force is a magnitude of a force. F is a magnitude of a force. So it is always measured in newtons. Then delta X is a displacement. Displacement is a displacement. Okay, it is always in meters. Then theta is an angle. The angle between the force and the displacement. Okay, the force and the displacement, or you can say the force and the direction of the motion. The direction of the motion. So that is theta, right? So we need to know that a force, what work that is done on an object is a scalar quantity. It is a scalar quantity, which means it has only the size, no direction for the work that is done on an object. Okay, what is important here when you are dealing with work, since there is a force here and the force is involved, so which means if you are dealing with a work, you must draw a free body diagram first, then you deal with each force. Now let's have one example for now, the simplest one. So let's say we have the object here, the object that is moving on a horizontal surface. The object that is moving on a horizontal surface, and the force is applied to an object. Okay, is applied to an object. Okay, to displace the object to the distance, which is to displace it to 10 meters. Okay, 10 meters. Let's assume that there is a frictional force, maybe it's 2 newtons. That is the frictional force of this object. So if the question says calculate the work done by the force applied, work done by the friction, by the weight, by the normal force, the first thing that you need to do is to draw a labeled free body diagram first. So let's draw the free body diagram. We have the normal force, we have the weight, and as you can see, we also have the friction and the force applied. So the free body diagram that we have now is this one. Okay, so I said the first thing that you need to do is to draw a free body diagram. There is a force applied here, and there is that frictional force, which is 2 newtons. Okay, so we know this one is equal to 10 newtons, and we know the frictional force is equal to 2 newtons. Okay, now we are going to calculate the work done by each force here. Okay, we are going to calculate the work done by each force. Let's start with the work done by the force applied. So the formula for the work is the force times delta X cos theta. Now the force that we are talking about now is a force applied, which means we are going to calculate the work done by force applied. So we need the force applied, which is 10. So the force applied is 10 times the displacement. The displacement, if we go back to the diagram, is 10 meters. So that is the displacement is 10 meters. Cos the angle now is the angle between the displacement. Remember the displacement, this object is shifting in this direction, and also the force applied is in the same direction as displacement. therefore the angle is 0 degrees. Okay, so we are going to put 0 degrees here. So the answer is 100 joules, is 100 joules. So the answer is positive. That is work done by force applied. The angle is 0 because they are going to the same direction as the motion or as the displacement. Now let's go to calculate the work done by the normal force. But we do not have the normal force, but we know that the normal force and the weight are forces that are equal in the opposite direction. In this case, they are balanced. Therefore, the normal force is equal to the weight. So the weight is mg. So the mass is 2 times g is always 9,8. So we have 19,60 newtons. That is the normal force. Now we want to calculate the work done by the normal force. So the work done by normal force, it will be the normal force times delta x cos theta. So the normal force is equal to 19,6 times delta x is equal to 10 times cos the angle for the normal force. Now the motion of the object is in this direction, then the normal force is vertical, therefore the angle here is 90 degrees. So the angle for the normal force is 90 degrees. Okay, so we have 90 degrees. Now if you press the calculator, you are going to get 0 joules, which means the normal force is always doing a negative work. There is no need to calculate it because even the definition of the normal force says it is a force or a component of force that a surface exerts on an object in contact with it and acts perpendicular, which means the angle will always be 90 degrees. Therefore, the work done by normal force will always be equal to 0. The reason is that it is perpendicular to the displacement. Therefore, the normal force will always give you a 0 work. Okay, now let's go to the diagram, free body diagram. Now we are about to calculate the work done by the frictional force. If this was 0 and this one is 90, then from here to here the angle is, from here to here is 90 plus that 90. So from here to the frictional force, the angle is 180. Since the frictional force is opposing the motion, so the angle there will always be equal to 180, the angle. So the work done by frictional force will be equal to a frictional force times delta x cos theta. Now let's substitute. The frictional force is equal to 2. The displacement is equal to 10. Cos the angle is equal to 180, opposes the motion. So for a frictional force, you will always just put that 180. Okay, so we have negative 20 joules. So that negative tells us that the frictional force decreases the speed of an object. Okay, so ayisixeleli direction. I hope that is clear. Now let's calculate the work done by weight. This is the weight, this is the displacement. So there is 90 degrees here, which means for the weight the angle is 90 degrees. Okay, so work done by the weight, will be equal to a weight times delta x cos theta. Alright, then which is equal to the weight is the same as that normal force, this normal force. So it's 19,60 times 10 cos the angle is 90, as you can see, is 90 degrees. Therefore the answer is 0 joules. Since now the angle between this displacement or the direction of a motion is equal to 90. Therefore, the work done by weight is 0 joules. It is not always 0 joules, okay? So we need to take care of that. But if you can look at normal force, the work done by normal force yona will always be 0 because the angle will always be what? Be 90 degrees, okay? And the work done by friction will always be negative because the angle will always be 180 degrees. Now let's check for another example. Okay, all right, let's look for another example. So this question says calculate the net work done on the box. Now the 10 kg is at an angle, right? So the first thing that you need to do is to draw a free body diagram, right? So we already have the frictional force and the force applied. So there is always the weight, then we have the what? The normal force. Remember, the normal force is always perpendicular to the surface. Now we are going to draw a free body diagram. So the displacement is the same as that one, is 10 meters. So we are going to answer this question. Calculate the net work done is the total work done on the what? On the box, which means we are going to calculate the work done for each force, then we combine them, right? We combine them, then we see the net work done on the object. Okay, so we also have the weight here. Now let's go continue. The frictional force is the same as that one. For now, the frictional force is that 2 newtons, right? So we are going to start with work done by the force applied. Now the angle between the displacement and the force is what? Is 30 degrees. So we are going to calculate the work done by the force applied. It will be the force applied times delta x cos theta. Now, the force applied is the same as that 10. Then the displacement is also that 10 cos. The angle now is 30 degrees, not 0. Remember, the force applied is applied at an angle, which means the angle now is not 0 because it is between the displacement and the force. I-angle esijongayo angle between i-displacement ne-force. Asijongi enye angle. Okay, I will have an example for an incline. So the answer for this one is equal to, the answer is equal to 86,60 joules. That is the work done by the force applied. Then we also calculate the work done by the normal force. Work done by the normal force. Remember, the displacement is in this direction. The displacement, that is delta x. Therefore, the angle here is 90. Since the angle, it is equal to 90 degrees. Therefore, the work done by normal force will be equal to 0 joules. I said the normal force will always be 0 joules. Now, let's do the work done by frictional force. So, the work done by frictional force is equal to the frictional force times delta x cos theta. Now, the frictional force is equal to 2, displacement is equal to 10. Since we are calculating the work done by friction, we just put 108 here. So here is always 90, then here is always 180 degrees, right? Then let's calculate. We are going to get negative 20 joules. Then we calculate the work done by the weight. The work done by weight is the weight, which was 19,6. Delta x is 10. cos, but the angle between the weight and the displacement is 90. So we have what? The 90 degrees here. Therefore, for now, the work done by the weight is equal to 0 joules. Now, the question said calculate the net work done, that is the total work done on the crate, which means we are going to combine all of these answers esinazo lapha, we get work net. So the work net will be equal to work done by force applied plus work done by normal force plus work done by frictional force plus work done by the weight. So the work done by force applied is 86,60 plus work done by normal force is 0 plus work done by frictional force is negative 20 plus work done by weight is equal to 0. So we are going to combine that. So the answer is 66,60 joules. This is the net work done on the block. Okay, now let's go to another example. Let's go to another example. All right, now we are dealing with an incline. We are still calculating the net work done. All right, the net work done. So in this case, the easiest way is to first deal with a triangle. Okay, so we have this triangle, we have delta x here, which was 10 meters. So here we also need the what? The height. Okay, so the height is what we need first. So after we have the height, everything we are is going to be simple. So we are going to use the sine ratio, which is a sine theta, which is equal to opposite over hypotenuse. So sine, the angle is what of this triangle is 30, is equal to the opposite is the height, that is the opposite side is the height. So divided by the hypotenuse is 10. Cross multiply. So h is equal to, if you press calculator here, 10 times sine 30 is supposed to be 5. So it should be 5 meters. 5 meters. So the height now is equal to 5 meters. Okay, the height is equal to 5 meters. 5 meters. Now let's draw the free body diagram. After that, so we have a normal force, we have the weight, which is always going down. So the free body diagram will be like this. This is the object itself. So we have a what? The force applied. We have a normal force in that direction. We have a frictional force in that direction. Then we have a weight always downwards. Okay, so now if you can look here, each force has its displacement a parallel kuyo. This one, this 10, sorry, let me fix that. These two forces have this displacement which is parallel to them, which is what? 10 meters. Then this one has the weight, the height which is 5 meters. So ilula ngohlobo ezi, this one ihamba nezi parallel to each to them, then sibe nale ihamba nala height besibala, which means it is very important to calculate la height so that yonke into izoba lula. Okay, now let's go. So let's calculate the work done by force applied. Work done by force applied, it will be a force applied delta x cos theta. Okay, so the force applied is still 10. The displacement that goes with what? With force applied is 10 meters. Cos the angle is, since the object is moving up an incline motion, therefore the angle here is 0 degrees. So the answer is 100 joules. Then we calculate work done by the normal force. We know that the work done by normal force is always 0 joules. Sorry for that. Then we have work done by frictional force. It will be a frictional force times delta x cos theta. Then frictional force is parallel to the displacement, which is 10. So the frictional force was 2 times displacement is 10. The angle is always 180 for the frictional force. So the answer is negative 20 joules. Then we calculate work done by weight. Work done by W, it will be W delta x cos theta, right? So the work done by W, it will be a weight. Weight was calculated before, it was 19,6 times the displacement that goes with what? With the weight is the height. Always just calculate the height, it will be easy. The height is 5. Then cos the angle, since the object is going upwards, therefore friction and the weight are opposing the motion, which means it's 180 here. Just put 180 there. Then you press the calculator, you have 19,6 times 5 cos 180. So the answer is negative 98 joules. All right, now we are going to combine everything here, then we calculate the work. Okay, the net work. So the net work done, net here is the work done by force applied, work done by weight, work done by friction, plus work done by the normal force. Okay, by the normal force, then we combine them. The force applied was 100, then the weight is negative 98, friction is negative 20, then the normal force is equal to 0. Now we are going to combine all of these. It's 100 minus 98 minus 20 plus 0 is equal to 18 joules, negative 18 joules, negative 18 joules. Therefore, the net work done is negative 18 joules. Okay, now let's go to the work energy theorem. Work energy theorem. Now, work energy theorem.